When an organization relies on localized, ad hoc desktop scripting, it builds a fragile network. These isolated scripts fail under enterprise load because they lack centralized exception handling. When a target application changes or a timeout occurs, the script simply breaks. Running these automated tasks on unmonitored desktop environments also introduces severe security vulnerabilities, leaving credential access and data processing largely unlogged. At an enterprise level, organizations must establish a secure, bidirectional flow of work between approved IT systems and the digital workers executing the tasks. Without architectural governance, automation programs generate compounding technical debt instead of scalable returns. To solve this, organizations deploy a robotic operating model, or ROM. This maps the 7 holistic foundations of the model. The technology is completely encapsulated by human and structural processes: vision, organization, and service model. IT hosts the central platform infrastructure, while the business controls the workload through a strict governance pipeline and delivery methodology. Separating these powers creates a secure environment where digital workers can process tasks autonomously without requiring constant human supervision. By deploying the ROM, organizations move from individual desktop tools towards a strictly governed, IT-backed enterprise capability. Inside that framework, a governance board serves as the ultimate gatekeeper for what actually gets built. Business representatives on this board evaluate strategic alignment and prioritize processes based strictly on projected returns. IT representatives manage the inward and outward dependencies, ensuring that digital workers will have the necessary system access before development starts. The head of RPA chairs the board, enforcing a predictable, scheduled review of all candidate processes. Demand flows to the board through proactive business requests and reactive triggers, like scheduled application migrations. Before any request is approved, it requires an initial process analysis, or IPA. The IPA acts as a ruthless first filter. It scores technical feasibility, assesses operational complexity, and required effort before a single line of code is written. Filtering demand through this governed pipeline prevents engineering teams from wasting resources on the wrong automations. Once a process clears the pipeline, the delivery phase must translate chaotic, intuitive human keystrokes into deterministic digital rules. To achieve this, the business process is forced through a mandatory pipeline of 3 distinct documentation gates. First is the process definition document, which records the exact keystroke-level flow of the task. A subject matter expert manually walks through this prescribed flow to expose any hidden workarounds. Next, the Functional Requirement Questionnaire defines the metrics and controls required for unattended execution. Finally, the Solution Design document synthesizes these requirements into a technical blueprint. This blueprint is submitted to the design authority. If the design requires bespoke solution features or custom code stages, it cannot proceed to the build phase without explicit approval. Executing this rigid documentation chain eliminates developer guesswork. The final digital worker reflects the required enterprise architecture, not the individual preferences of the person writing the code. Following the build phase, the digital worker must be proven resilient. This validation is structured through a progressive 4-tiered testing pyramid. In the verification phase, developers step through the completed logic. They process live cases alongside subject matter experts, creating an iterative loop where edge cases are identified and fixed upon failure. The process then moves to user acceptance testing. During UAT, operations teams gradually ramp up case volume in an environment that exactly mirrors production, testing against scheduled tasks and live credentials. Testing the happy path is insufficient. The bot must also clear strict non-functional requirements. Resilience testing proves the process can independently recognize an unexpected system timeout, restart itself, and successfully recover an orphaned case. Digital workers achieve enterprise-grade status only when they demonstrate the capacity to survive and gracefully recover from inevitable system outages. Right now, the industry is rapidly integrating generative AI and autonomous agents capable of executing complex, unstructured tasks. This creates an infrastructure conflict. Enterprises require cloud agility to deploy these innovations, but compliance standards prevent them from exposing sensitive, regulated data to external networks. The resolution is a next-gen hybrid architecture. In the upper tier, a cloud-based control center manages worker health, telemetry, and schedules. In the lower tier, self-hosted digital workers execute tasks securely on the organization's network. Sensitive data is processed locally and never crosses the firewall. This model removes the burden of infrastructure maintenance from IT teams while operating entirely within established compliance parameters. By decoupling the orchestration layer from the execution layer, enterprises achieve cloud scale without compromising data sovereignty. The final component required to integrate these tools is the AI gateway. The gateway acts as a strict firewall, dictating exactly how external generative AI tools interact with internal corporate workflows. With an integrated agent builder, centers of excellence can fine-tune specialized AI models securely behind this defensive layer. These agentic workflows do not operate in a vacuum. They connect directly back to the foundational principles of the robotic operating model. Because the ROM enforces a traceable audit trail and stage-gated submissions, deploying AI inside the enterprise becomes a repeatable and highly monitored process. The end state is the automation fabric, an ecosystem where human employees, deterministic digital workers, and dynamic AI agents collaborate seamlessly to execute mission-critical work. Engineering the architectural framework required to govern these autonomous agents is what establishes the control necessary